So welcome everybody to this latest A2 video on 162 Maths, and in this video we'll be looking at numerical methods with a focus of the trapezium rule. Now we'll put a copy of some notes and a worksheet in the description below for your own records and for you to practice the contents of this video. So another way of finding the area under a curve is to draw trapeziums over the range required and then find the total of their individual areas. Now although this is not an accurate and may give either an overestimate or an overestimate, it does provide us with a suitable approximation of its area without actually integrating. Now many questions are always asked is, why do we even use this method when we can just integrate it? Well, this method comes into play when the equation or the function is incredibly difficult to integrate, so when it goes beyond the realms of using integration by substitution or by parts. So let's have a look at an example of what we're actually talking about. So if I just draw a curve, and let me just call this function f of x, and let's say I want to work out the area of a given range under that curve. So let me just do this properly and draw sort of straight lines from so, and let me go for another one. And if these limits were a and b, this is the middle area is what I'm wanting. So what I'm wanting to do is to work out the area between b and a of f of x dx. Now again, we could integrate, but let's just assume that we can't because the function is just ridiculously difficult or quite complex. So what we're going to do instead is we're going to split this range into strips. So just to save a bit of time, I'm going to split this up into equal 3 strips. So here is my first strip. Here is my second strip. And let me just rebrand this strip here as yellow. Now, what we're talking about here is to find the area. Now, if this was on squared paper, I could just simply count the squares, and to get it more accurate, I would use smaller squares or graph paper, like actual 1mm graph paper. But again, looking at this, what we're going to do is, instead of using counting squares, what we're going to do is going to turn these strips into trapezium. So what I'm going to do is I'm going to draw a straight line, and let me just make sure that this comes up clear. So from this point, I'm going to join it up with that strip. Then I'm going to get another one and join another trapezium like so. And what hopefully you can see is that the roofs of these trapeziums is pretty close to the curve. Obviously some might go over, some might go under. Now what we're going to do is we're actually going to work out the area of each of these trapeziums. So if I just call this strip trapezium 1, this trapezium 2, and this strip trapezium 3. Now in terms of the area of a trapezium, if you remember that the formula is a plus b times h divided by 2, or if you wanted you could write it like so. You could also use a half, but we're just going to go for it like this. So what I need to do is find the areas of each of these trapeziums. Now looking at this, my trapeziums are looking like this. So my two parallel sides, my A and B, are going to be to the two vertical lines, and my height is going to be the horizontal length here. So this represents h, and they're the perpendicular heights of each of those three trapeziums. Now what I need to do is find what the parallel lines of these trapeziums are going to be. So what I'm going to do is I'm going to call this point XO, this X1, X2, X3. Now the reason why I'm starting with XO is because I'm actually starting on the actual starting line. I'm not actually counting one up. So when you think about a number line, when you take a step forward, you count that as one, but we can go from there. So from this, what we then wanted to work out is that these heights here are going to be Y0, Y1, Y2 and Y3. Now how to find those Y values? So to find the Y values, well, all I need to do is simply sub the X ordinates into the equation. And what that will do is by working out what the X, Y ordinates are, it would actually give you the height from that X axis. So from this, if we look at what T1 is, So the area of trapezium 1, well, that is going to be h over 2. And then it's going to be my first length, which is y0, plus y1. Then the area of T2 is going to be h over 2. And their two perpendicular parallel lines are going to be y1 plus y2. And the area of trapezium 3 is going to be h over 2, y2 plus y3. Now, to work out the area under the curve between the ranges of A and B, all I need to do is simply add those three trapeziums up. So here I'm going to have h over 2 plus y0 plus y1 plus h over 2 y1 plus y2 plus h over 2 of y2 plus y3. Now, if I do a bit of factorising, what I find is I've got common factors of h over 2. Then I've got y0 plus, and I've got two lots of y1. I've got two lots of y2. And then I've just got a single y3. And that therefore would give me the area under that curve between the limits of A and B. Now, what this then leads into is we can sort of summarize this into our trapezium rule formula. Now, the good thing about this, although it looks quite complicated, it's actually not that bad, is that it is given to you in the formula book. So it is something that you need to, that you don't need to remember, but you do need to remember the components, what each of the letters and things represent, and obviously how to work this out. So this formula here is given in the formula book. Let me just make a note. So given in the formula book. And it's worth just reminding yourself, just have a look at the formula book to see how it is represented. Sometimes they use different sort of notation, letters. It's something to just bear in mind. So here we've got our formula where h, which is the height of the trapezium, is, and the best way to do that is do the two limits, take away the difference to the two limits, and then n is the number of strips. So basically how many trapeziums you're going to have. And also another thing that's worth adding is that sometimes in some questions, they may give you how many strips they want. Sometimes they may tell you how many ordinates they want. So the number of strips equals the number of ordinates minus 1. Now, in terms of the method, there's several ways in which you can do this, but I would say these 7 steps usually represent everything that we need to do. Now, obviously, these 7 steps may make absolutely no sense to you at all before we've even attempted a question, but hopefully, if once you've noted this down and you get stuck on one of these types of questions, you can follow these 7 steps to hopefully guide you to getting the correct answer. So the first one is to decide on the number of strips n. Now, again, this is sometimes most likely going to be given to you a question, but as I've mentioned, sometimes you may be given the number of ordinates, in which the number of ordinates, take away 1, it gives you the number of strips. You then want to find your h using the formula, then draw a table of values with x ordinates starting with A going up in increments of h until you get to B. Then you find your respective y ordinates by substituting the values of x into the equation. You label your y ordinates starting with y0 and ending with yn, and then use the trapezium rule or substitute the values into the formula. And then finally, when you got your answer, you want to write your answer to a suitable degree of accuracy. Now, another thing that you might want to do is, I would say, check the sort of accuracy of your answer on your calculator. And that's by actually physically working this out. So you just simply, on most calculators, you've got an integral button, which should look something like this. Now, if you actually entered all the information, press equals, it will just give you values with no working out, just tell you what the answer is. And if you've done it right, then your answers should be very, very similar to the actual accurate answer. So let's get started on an actual example. So this question says that use a trapezium rule with 4 strips to find an approximate value for and then we've got our integral of 1 over 1 plus root x dx between the limits of 16 and 4. State whether it's an underestimate or an overestimate and how the approximation could be more accurate. So here we've got kind of 3 questions all rolled into one, and you will find that when you're practicing these questions, the questions are written extremely similar. So they'll tell you to use the trapezium rule, they'll tell you how many trapeziums, how many strips or ordinates to use, they will give you the formula. And then in this question, it's asking whether it's an overestimate or underestimate, which usually tends to be a part C and only worth 1 mark. And then also another 1 mark question, which is how could the approximation be made more accurate. So let's have a look at how we do. So I'm going to try and follow those 7 steps on the that I've gone through on the method. So the first thing we need to do first is calculate H. Now in terms of this, well, we know that we've got 4 strips. So here we know that we've got 4 strips. That's not a problem. So then for step 2, we then want to work out what H is. Now H is the upper limit, take away the lower limit, or divided by the number of strips, which gives me an answer of 2. So step 3, what we then need to do is to draw our table of values. So in terms of this, we've got X, we've got Y, and I'm going to start with our lower limit, and what I'm going to do is I'm going to go up in 2. So I've got 6, 8, 10, 12, 14 and 16, and that's where I'm going to stop. Now the next thing I then need to do is to find the y ordinates. Now for this, what I need to do is simply, if I just put this little bubble around this, all I'm going to do is substitute the x ordinate into this formula here. So it's going to be 1 over 1 plus root 4, and if I word that out, I get an answer of 1/3. Then for the second one, let's use different colors. So for this one here, I'm going to do 1 over, and it's going to be 1 plus root 6. And again, what answer should I get there? Well, it's going to be around about 0.2898, so 4 decimal places. I then repeat the process. So for this one here, I'm going to do 1 over 1 plus root 8 rather. Change that to an 8. And that should give me an answer of 0.2612, and then repeat the process. So for when I use 10, I should have 0.2402, 0.224, 0.2108, and finally 0.2. Now the next thing I then need to do is label these points. So this blue value 1/3 is y0, this value here is y1, this is y2, this is y3, that is y4, that is y5, and finally this is y6. So y6 is my equivalent to yn. Then from this, what I then want to do is then substitute these numbers into the formula. So what I'm going to do is I'm going to write this correctly. So I've got 16 over 4 of 1 over 1 plus root x dx equals, and then I just need to substitute the values in the formula. So I've got h over 2, which is 2 over 2, over then y0, which is 1/3, plus 2 lots of all of these numbers apart from the last one. So I've got 0.2898 plus 0.2612 plus 0.2402 plus 0.224 plus 0.2108, close bracket, plus 0.2. And if I type that all into my calculator as accurate as I can be, then what I should end up with is 2.99 to 3 decimal places, and it's going to be in square units. Now in terms of state of whether it's underestimate or overestimate, well, if I then reach for my calculator, and let me just see if it has got a, yes it has, so I can just do this. And if I then just type in the numbers, so let me just enter the formula. So I've got 1 and then 1 plus root x. There we go. And then if I just enter the limit, so I've got 4 and I've got 16, press equals, and it comes up with 2.978. So how does that compare with 2.99? Well, it's pretty close. So the actual answer or area is 2.97. So my guess, or the approximation is an overestimate. Now, if I was asked to draw the curve, so for example, do a little sketch of what it looked like, then what you find, as it's an overestimate, basically the roofs of those diagonal lines of each of the trapeziums will be above the line. If it's below the line, that's going to be an underestimate. So you might get a question where you might be asked to sketch. And then finally, with regards to how can the approximation be made more accurate? Well, this is basically a common question that comes up, but an answer that satisfies all those types of questions and never deviates from the answer is basically draw or use more trapeziums or strips, depending on whichever floats your boat. So let's have a look at this second example. So it says, using the trapezium rule, find the approximate value of sine x dx between the range of pi over 2 and 0 using 5 ordinates, giving your answer to 3 significant figures. Now, before we get started on this, we know that straight away we've been asked to use the trapezium rule. Now, there are 2 other rules that you can use in numerical methods. One's called the minimum rule, the other rule is called Simpson's rule. So that's why they kind of define which rule they want you to use, because obviously, but the other 2 are valid ways of approximating the area under a curve without integrating. But again, they're kind of coercing you to use this particular rule, which is why they'd always state it. Now with this, we notice that looking at the formula that we've got using trig ratios, and we've got something involving pi. Now this will always imply, so whenever you use a trig ratio or pi, set your calc to radian mode. And that's really important when it comes to actually substituting the values in to find your y ordinates. And we've also noted that in this particular question, it's not told us how many strips to use, but it's how many ordinates to use. So 5 ordinates basically means 4 strips. So in terms of this, n equals 4. So to find out what h is, it's going to be our upper limit, which is pi over 2 minus 0, all divided by 4, which gives me pi over 8. Now that comes in handy when it comes to me drawing my table. So if I then draw my table of values, so I've got x and I've got y, and I've got my starting value with 0. Now with h, all I'm going to do is I'm just going to add pi over 8. So then that next one's going to be pi over 8. Add another pi over 8, which gives me 2 pi over 8, which is just pi over 4. Then I've add another pi over 8, and that gives me 3 pi over 8, which can't be simplified, so I leave that as it is. Add another pi over 8, and that gives me 4 pi over 8, which is pi over 2, which is my upper limit, which is where I stop. Then all I then need to do is substitute the values in. So this value here is going to be sine of 0. This is going to be sine of pi over 8. This value here is going to be sine of pi over 4. This is going to be sine 3 pi over 8. And this value here is going to be sine pi over 2, remembering to make sure that you are in radian mode. Now in terms of working out those values, so this first one should be 0, this is going to be 0.383. Now if you are writing decimals, I would always recommend that you go a couple more than what they want the final answer to be. So if they want the answer to 3 sig fig, then in your values, in your table of values, I would go to 4 or 5 just to make sure, because accuracy is key. I know that I'm not writing it down, but they say because I've got small space, but hopefully I'm going to be using the exact values anyway. So then for the next one, we've got 0.707, 0.924, and then we've got 1. So substitute, once I've got those in, I can then label these values. So this is my y0, this is my y1, y2, y3, y4, or yn, which is my n value. So substituting those numbers into the formula. So again, just good practice to write it all up. So I've got sine x dx equals, one, because it's actually going to be approximation, so let's use our squiggly equal sign. So here I've got h, which is pi over 8 over 2, and then I've got to substitute my numbers, so I've got 0, let's put that in there, 0 plus 2 lots. Now you can, because the formula is, or the equation is relatively quite simple in terms of how many terms it's got, I'm actually going to use the exact values where possible. So here I've got 2 lots of sine pi over 8. Now you could have used the decimal equivalent, so the numbers I've written in red, that would be absolutely fine, but again, just be wary of the accuracy of those in terms of the decimal places or sig fig. Pi over 4 plus sine 3 pi over 8, and then close bracket plus, and then it's just 1. So if I enter all of that into my calculator, I should end up with a value of 0.98723 sig fig square units. Now, would you lose marks if you didn't write square units? Probably not, but again, because of working with area, that's what we're looking at. Now again, if I wanted to, I can check my answer. So let's just check that out. And again, so let's make sure we're in radian mode, which we can do here. So let's put option 4, press the integral button. So I'm working out sine alpha x, close bracket, and then our lower limit is 0. Our upper limit is pi over 2. Press equals, and I get 1. So is our answer pretty close to 1? Yes. But again, as you can see here, that by calculating the actual answer, which is 1, we can see that this here is an underestimate. And again, it's not asked me to work that out, but again, it's always worth just checking your answer to see what it should get and what it should be, and see if you've obviously clearly made a mistake in terms of there. Now, I will put some practice questions in the description below, along with the answers to check to make sure you are. You will find that a lot of these questions are very, very similar. The only thing that changes is the number of strips, the function, and maybe how they want their answer. But it definitely takes a bit of practice. If anything, it's getting you practice, use your calculator, use your accuracy, and just making sure you're not making any silly mistakes.